In the last video of this series, we went ahead and installed the Flipsky FT85BD ESC into the Meepo MLR. Wow, that's a mouthful. In any case, we're going to be programming the ESC in this video, and I think this is a very interesting process and will probably be helpful to a lot of people. So let's get this thing configured. Now, I'd like to say that this started off on a perfectly smooth path and that everything worked perfectly. However, I've never used this software before, and I didn't really know exactly what I was in for. And this, well, what happened isn't necessarily the software's fault, but let me just explain it. In this first clip, I recorded myself talking about installing the firmware. If you can see on screen, I don't have a screen recording for this part, but it says that the ESC firmware does not match the software firmware. Basically what that means is that you need to update it. And unfortunately, I didn't realize this, but when they sent me the ESC, the USB cable was plugged into the slave header on the mother, or on the board itself. And that's not where you're supposed to start a firmware flash. Unfortunately, there's also no safeguard to stop you from doing this. So I ended up flashing new firmware onto the slave side of the ESC, and then I got stuck. Once you flash firmware on the slave side, you can't connect to the master side through CAN anymore, at least on this firmware update. And what that translates to is when you swap the USB over to the other side, you really don't get any useful response and you can't program the ESC. So you end up with one half the ESC on one firmware version and the other half on the other. The way that I got around this and fixed it was going back to Flipsky's site, downloading the old tool, flashing the old firmware that it came on, or came with, back onto the slave ESC, and then I was able to switch the cable over from the slave ESC to the master ESC and start the firmware process again. So that's where we are in the next clip. So we're back now. Both are on the 1.5 firmware. So I do want to update though. So what I'm going to do now, we're plugged into the marked master side on the ESC, and we're going to try updating the firmware from the master side first. So we'll enter bootloader. It's flashing. Connect. Start flashing. Should update the master side. And then we'll switch to the slave side. Load the bootloader there and update it there as well. So now this should say nothing. Also, I was confused before because it says does not match when it's wrong, and it says match when it's right. So switch the cable over, see if it'll connect this time. Perfect. So you have to update the master side first. And I actually do have the 94-page user guide open on the screen above here. I didn't find that information in there, but there's a lot of great stuff in there about how to set up the ESC, so we're going to be using that information when we go through the rest of the setup. But now it looks like we're good, so that's great. There we go, 1.6. Both sides are now on 1.6. So usually you want to perform all of your detections and everything from the master side, so I'm going to switch the cable back to the master side now. And now that we're back on the master side, we can start by doing motor detection. And I believe this is fairly similar to VESC tool. I did try motor detection already, but it was on the wrong firmware. So we'll configure a little bit of info here. 100 amps for these 6890 seems perfectly doable. And then 16S. And then we'll hit, we'll make sure CAN bus is check marked, and then we hit the little start motor identification button. It gives you a warning. This is pretty much the same as VESC tool. if you put too much current, it could burn out the motor, blah, blah, blah. We should be good. It's going to make some horrible sounds, and you guys can look at it over here. Very loud. And that is your motor detection finished. Perfect. So it actually like errored out weirdly last time because the firmwares didn't match. This time it looks like it went through properly. So 27 milliohms, 21 micro Henry, 6.4, 6.3 on the motor flex. It all seems reasonable, I think. I don't really know, but it seems comparable to VESC tool. And both Hall sensors detected, so I think we did configure those correctly, so that's excellent. Now we can go and write setup and move on to the next step. Alright, so there are a number of things you can configure on here. A lot of it is behind this scroll area. Oh, apparently I got sucked into that. Anyway, there's a scroll bar here. It's a little hard to see, but that's where all of your settings are for the motor setup. So ESC basic setup, you have startup mode. There's a number of options here. I'm going to use Hall because I have Hall sensors, so no reason to change it. HFPI information is like, I think it's like HFI on VESC, but a little different because it's Flipsky ESC. Motor temp NTC, this is something that I don't know. I'm not sure if I'm going to be able to figure out this beta to get accurate temperature readings from these motors. I'll probably look up how to determine that. When I measured the thermistor itself, it was around 12 kiloohms, like I said, but that's not what this is. This is different. So, zero duty mode, I don't know what that means. Let me see if I can find it in the thing here. I have the user guide up above, like I said. So I'm looking up to see what I can gain here. So zero duty mode, I don't think that's going to matter for Eastgate. It says if set duty cycle is 0 in zero duty mode, you can either keep the output or release motor. We're not using duty mode, so that probably doesn't matter. Next line, power on beeping hint. So this is, you can have the ESC beep when it powers on. I actually kind of like that, so I'll turn it on and see what it sounds like. Observer ERPM threshold. So I think this is going to be the switching mode from Hall sensor over to observer mode. So, oh, I need to pull my laptop in. 3388 RPM, ERPM sounds fine in my head. I don't know what it is on VESC by default, but you really don't need Hall sensors for very long. When you're riding, it only needs it for like the first second while it's trying to figure out what the motor position is, so that shouldn't be an issue. So we'll leave that be. I just realized I had the wrong scene selected in my recording software, so sorry about that. Anyway, we are going through the motor settings. FOC brake mode. So this is something that I don't really understand. Hard to explain. Hopefully not a problem. Duty detected, ERPM detected, or duty ERPM detected. It's basically telling you like which braking mode is going to get activated. Maybe I'll put a screenshot from page 27 of the user manual. It sounds like with duty detected, when you enter brake status and detect the duty cycle is lower than 0.001, aka like 0, switch to 3-phase short circuit, which basically means you just short two the motor phases together. That's like a super hard brake. That sounds interesting. Okay, all of the settings for this are just determining when it does the short circuit. So I do want it to do it at 0, not at an ERPM. So that makes sense. Brake ERPM threshold. This is the same thing. That's where you would set it if you checked the ERPM 1. Fill weakening control, we're just not going to turn that on right now. Maybe we'll mess around with it later to get some top speed back on the MLR, but I'm not going to mess with that yet. Battery setup, cutoff start 3.4 volts, cutoff end 3.1 volts, I like it. Regen start voltage, regen end absolute max at 4.35, that's fine. 16S in series. I don't know what bus voltage resistance means, but that's for your operating on a power supply, so that's not relevant. Max ERPM setup. So this ESC actually has some interesting modes that you can build in using these gears, and these are swappable using the VX4 remote. So this will be interesting to play with. I think I'm just going to leave them as default right now. Maximum negative ERPM 200,000, maximum positive 200,000, that's fine. It looks like gear 1 is 5,000 RPM, gear 2 is M 20,000, gear 3 is H 100,000 ERPM. I don't even think we're going to max out at ERPM at 100,000. And then we also have gear R, which sounds like reverse mode, 3,500 ERPM. That sounds really slow, but maybe we'll just have to mess with it and see. All these are configurable in the app, by the way, so once your enclosure's closed up, you can use your phone to change these, but I had to do the firmware updates on the computer. Max power setup, it looks like you can set wattage limits. It looks like the gears have an ERPM and wattage limit. So maximum of 2,000 watts. I'm not sure if this is per side. So like the output voltage to the motor times the output amps equaling this, or if this is total, or if it's battery. Doesn't really explain that in the user manual, but it just says they're adjustable. These extra gears above the H, so like 4, 5, 6, are only available in PAS control mode. Not sure what that is, but I don't think that's important. Current setup. So this is where you're setting how much amps you send to your motor. Right now we have it set at 100 minus 100. That's the max that it will allow for. That's the max continuous that it will allow. You can probably bump this up, but I'm going to start at 100, see how the motors do, make sure everything is cool, and then we'll bump it up from there. 50 amps battery. I really want to be careful with this battery amps because I think the Meepo battery has a discharge BMS and it maxes out at 100. So I probably should set this to like 49, 48 or so, because Vest likes to run over a little bit. And negative 50 amps for regen. Probably going to turn this down a little bit to negative 30. See how the brakes are, and if we need to, we'll turn it back up. Limitation, battery low voltage, battery high voltage. Don't really need to touch those most of the time. MOSFET overcurrent, 300 amps. MOSFET over temp, 90C. Yeah, seems like a decent cutoff. Coder setup, we're not using that. Speed PID, we're not using PID mode. So that pretty much covers all the motor settings. So we'll hit right setup. Duplicate this on the other ESC by switching multi ESCs to slave here. And then we'll move on to the control setup. Alright, I just read through the whole control section of the user manual. These first set items I don't really care about for my setup. ESC ID, CAN status, other CAN stuff. Multi-ESC sync. I do think this is supposed to be on since they're CAN ESCs. Throttle response level. So it says standard level 4 is good. Obviously you can play around with this, but I'm assuming, at least from what it says here, the lower the level, the less sensitive it is. So we do want it to be pretty sensitive. And then input signal deadband percent, I'm going to set this really low at like 3% because the VX4 already has 5% set in there. And the user guide says you can set it at 0 and then it's just on the remote. So I think I'm going to leave it at 3%. So cumulatively, that's 8% total. I think that's about good. We'll just have to play with it and ride it and see what it feels like. So this smart switch section, this is basically auto shutdown. And I think I'm going to put it at 1 hour later. So 1 hour of no drive input, it'll turn off the ESC. This is compatible with the FT85, FT60, FT85KS. I think that's it. Brake light level. This is for the brake light that you can hook up to the ESC. We're not hooking it up right now, so I'll set that later. There is a whole traction control section. I'm going to leave it off right now. Maybe we'll mess around with it in a future video. Emergency switch. I think this is like a kill switch for stuff like go-karts or other vehicles. Signal ramp up time. This is probably similar to the ramp time that you see in VESC tool. I'm going to leave it. If it's not responsive enough, we'll mess with it later. Now, the next important thing is the control setup. So it actually describes all of them. PAS is a pedaling sensor. Okay, powered assist, I'm assuming that's what that is. So we're going to be selecting UART since we're using the VX4. And now you get to select your control mode. So I think you have to do this on both sides of the ESC. So control mode, we're going to do gear. What's the difference between gear and current? Let's see. Okay, so current reverse brake does not use the speed gears. Current gear does. Current gear reverse brake or current gear brake. Let's try current gear reverse brake. Basically, that'll let us use the MH or the LMH modes to set speed. That'll be cool. Extra interface is for other accessories. We don't have any hooked up right now. Reverse delay time. So once you stop, how long is it going to be before it goes into reverse? I think 5 seconds is pretty high. Let's do 3 seconds. Because this is after the motor is stopped. So assisted turnaround mode. This is for like tank mode. Interesting, but I'm not turning it on. Brake parking mode. That is going to be hold the remote control throttle gear 0.5 seconds to enter parking mode. Greater percentage of pulling back the throttle gear. I don't think that this works when you have reverse turned on. It injects current in the motor to generate magnetic force and achieve parking effect. So current will be assumed with parking. Oh, so this is hill hold. That's actually really cool. The maximum it can reach is the motor current max, so up to 100 amps. That's really cool. Good to have. When in reverse mode, max pulling the throttle gear bar into the brake parking mode, but enter reverse mode instead. Okay, so I guess that means this is really for current reverse or current gear brake or current brake. That's fine. Maybe I'll mess around with that. I do prefer to just roll back up the hill, but I'm not sure how that works with like if you're rolling down a hill, is it going to think that the motor has stopped? I don't know. Off-road climbing mode sounds cool. This is not an off-road board, so I'm not going to do anything with it. But it sounds like it's supposed to be like a digital, like, differential lock. Next two sections, assisted turnaround, doesn't matter. Minimal current at 0 pedal doesn't matter either, because that's only for pedal assist mode. So that's pretty much all you need to do for UART setup. Pretty easy. So we'll make sure we hit right and then do it on the slave ESC. Alright, so according to the ESC tool, that's pretty much all you can do. If you want to use the testing tab in the tool to check your board before you use the remote, you can. However, now that I've set up UART control, this should just work. On the screen, you can see we have voltage here, 65.1 volts. A little bit discharged, 67.2 is max. We can see the ESC is at 31C and the motors are at 23.8. And it's currently locked, so we'll double press the throttle, or double press the power button, and we're just going to switch it to, oh, not that. Switch it to L mode. Let's see if this works. It should, as far as I can tell. Okay, it does work. However, we forgot one important thing. Ooh. So, one motor is spinning one way, the other one's spinning the other way. Obviously, that's not correct. So, what we're going to do is go into the tool and make sure we have the master side inversed. No, the master side is correct. We need to reverse the slave side. One thing I want to mention here, the VX4 has so much great information on here. When you're under throttle, you can actually see the ERPM there. And remember that 5,000 limit? Sitting right at it. 5,000 is pretty dang slow, so probably going to want to increase the speed of gear 1. You can see the motor current, battery current. I think that's supposed to be duty cycle, so once we flip that, it'll probably correct, but we'll see in a second. Okay, so we're connected to the slave ESC. We're going to go into ESC basic setup and change this rotation direction to negative. And we'll hit right, and we'll try again and see if it worked. As you can see, that has worked. And now both motors are going in the right direction. Actually, it is really hard for you to see. They were going in the opposite direction before, but now they're together. So 5,000 ERPM is like nothing. Let's switch modes. See what, I think the second one was 20,000, 4 times that. Now what's interesting, it seems like one motor is spinning faster than the other. Not sure why that is. It definitely is. Interesting. I'll have to figure that out, but 20,000 RPM does about 12.8 miles an hour. Now 100,000 I think is going to be the max speed, which should be like 30 something. A little bit risky to do here on the bench, so I'm going to go hold it. So the master side is working fine. The slave side is not, so it's making me wonder if maybe the slave side didn't do motor detection properly. So let's go back and do motor detection on the slave side. Alright, so I just redid motor detection. See if that made any difference. What's weird is this motor turned faster in motor detection than this one did. That doesn't really make sense to me. Oh, I was like, what? It's possible that this is just because it's on a bench setup and maybe this motor has more resistance on the bench, but I'm not sure. We'll switch back into L. Looks about the same in L. I did switch it to 10,000 RPM, which is only 6 miles an hour, but this one is at 30 now. I wonder if this is a deadband thing actually. Let me check that. There it is. Forgot to set the input signal deadband. Right. Perfect. Nearly perfect anyway. I do think one motor is turning, or is a little louder. So that's probably why we hear such a difference, but you're not going to hear the difference. I hear it. .9 miles an hour on bench. Seems within expectations. All sounds pretty good. I'm pretty happy with this setup. Obviously, we'll be able to mess with this through the app and adjust stuff as needed. We'll adjust the gears, potentially the power limits, and we'll just see how it plays out. So, was the install successful? Well, I sure think so. And honestly, I've done a tiny bit of performance testing so far, and I've been really impressed with how this performs. It's super smooth, the acceleration is surprisingly good, and I haven't even maxed it out yet. So, I'll be super excited to do the full performance test, which will be the next video in this short series, I guess. And we're going to do the full performance testing that I do for all of the boards that I review. And then we'll compare it directly to the numbers from the JKESC and see if this ESC is worth your time. I think it is. That said, thank you so much for watching. Hopefully you enjoyed this video, and get subscribed for the next one. Stay safe, keep on running, and peace out.